Hi everybody, my name is Kiki Dimitriadou, and in this video I'm going to show you our system named the AIDE, an automatic user navigation system for interactive data exploration. Uh, it's a system that we showcased in VLTP 2015, and basically our system deals with a set of discovery-oriented applications where we have a user trying to discover some kind of interesting information inside the database. Usually, in the current state of the art, the user sends a query to the database, he looks into the results, the database return, and on the basis of these results, the user refines his query, sends it back to the database, and this process keeps repeating and repeating until the user finally has found something that satisfies his interests. So as we can understand, this is a labor-intensive process where the correct query predicates, the target query predicates, are not clearly defined or known to the user at the beginning of the exploration. In our case, we have developed a system that actually never asks the user to write queries and send them to the database. In fact, the only thing that we ask for the user is his relevance feedback on some strategically selected samples from the database. What we do is that we select some samples, or we can call them tuples, from the database, we present them to the user, and we ask the user, is this sample relevant to your search or not? And after the user gives us his feedback, we can navigate him through the database and finally predict his interests. As we do this, we try to optimize both the efficiency of the system as well as the effectiveness. We try to ask for labels for as few samples as possible, and we try to have an interactive system where the user doesn't wait for us to come back with the samples. So here is the system we have built. So here we can see this is our initial page, and we use, for the demonstration purposes, we are going to use a housing database that contains information about houses. So let's say that you're interested to buy a house, but you don't really know what kind of house you want to buy. So in this page we can see all the attributes in the database. So we have the price of the house, number of beds, number of baths, the size of the house, the price per square feet, and then we have some interesting attributes for the town that the house belongs. So annual crimes, the crime rate per 1,000 residents, the population of the town, percentage of adults with bachelor's degree, and the per capita income for that town. So let's say the user is interested in the price attributes, the beds, the baths, population, and we can move on to the next page. So in this page, we can see the minimum and the maximum value for each of these attributes the user selected, as well as we can get an in-depth view at some of these attributes. So we can see that the price, if we draw the equi-width plot, we can see that most of the houses have a price between almost 20,000 to around 567,000. We have 444 houses with this value, and we can also see the equi-depth plot. We can see that most of the houses have a value from around 400,000 to 439,000. We can also plot the one-dimensional heat map for this attribute, as well as a two-dimensional heat map. So this might be more interesting. We can see the price and the beds, and we aggregate on count, so we can see that most of the houses in the database have bedrooms that range from 1.8 bedrooms, so around 2 bedrooms, and their value is up to 548,000. So after looking at this page, the user can decide if if some of these attributes are still worth exploring. For example, if we saw that one attribute had only one value in the entire domain, then the user might not choose to explore, or the user can specify a different minimum and maximum value for one of these attributes. So let's assume for the demo purposes that the user is interested in all of these attributes, and we can move on to our automatic exploration page. So this is our main automatic exploration page where we're gonna come up with samples for the user to label as relevant or non-relevant. So here, the first time I click start, we can see that the demo returns some samples, some houses basically, on a map. We use the Google Maps here, and if we put the mouse on top of one of these bubbles, we can see the price, the bedrooms, bathrooms, and population of the specific house at that location. So here we see that the price is 230,000. We can say, okay, this is a relevant sample, and we can label it as green. This is also a relevant sample. Let's say that the user is interested in houses less than 200 or 300,000. So let's say that this is a negative one. This is too expensive. We can also say this is definitely too expensive. This is also too expensive. This is much more expensive than all of the rest. So when I click next iteration, two things are going to happen. First of all, we can see that the tool has come up with a prediction for the user's interests based on the feedback the user gave. So the prediction that AIDE has done is that it says that the price is less than 375,000. So one thing is that the user can clearly see what his interests are here, and although he said initially that he's also interested in bedrooms, bathrooms, and the population, we can see that his interests only depend on the price at this moment. The second thing that happens is the system comes up with better samples by leveraging this model that is predicted for the user. So we can see that with black we have some new samples, while the gray ones were the initial samples. So as the user keeps playing, so this is obviously a house that has high value, we can say it's negative, also negative, negative. As the user keeps playing and labeling samples, so let's say that this is a positive sample, also a positive sample. Let's just say this is a positive sample as well. If we click next iteration, the user can either strengthen the current prediction, or like here, the system came up with a better prediction that shows better the user's interests. We can also switch and see the predictions in the two-dimensional space where we have the beds and the price. We see that the user is interested in this range. If for example we change to baths, beds and baths, we can see that the user's interests are, for the first area, is the entire space. Or if we see the second area and we see the bedrooms and price, here we can see that the user is only interested in this area. Houses that cost this much, from 500,000 to 1,500,000, and bedrooms from 4 up to 10. So when the user is finally satisfied with the prediction that the system has given, he can click all relevant objects, and the system will retrieve from the database all of the samples that satisfy this query predicates. And he can take some action or buy some house at this point. So how do our techniques work? So to show that, I will be using a different database, the SDSS database, which contains information about stars and galaxies in the sky. So this database is commonly used by astronomers if they want to make some discoveries. So here I have a predefined query that we will try to predict. The query uses the row C and col C attributes of the database. These attributes show the location of a star in the sky. So if I click star here, we can see that this is the target area that I will try to predict, and we can also see that the system has come up with these samples If I click here, picture, this is an actual star in the sky. This is the SDSS navigation tool built by SDSS astronomers. So we cannot really actually clearly see. There is a star here, but it's a small one, we cannot really see. But here, for example, let's try another one. If I click get image, here we can see there is a star and we can see some of the attributes for this star. So if we go back to our tool, if I click label, we can see that one of these stars falls inside our target area. It's relevant for the user, and so the user has labeled it as relevant. So in the next iteration, if I click next iteration, what happens is that the machine learning algorithm we use, which comes up with a model that predicts the user's interests. In this case, we can see that there is no, the entire data space is red, which means that there is no prediction currently. That means that although this sample, this star, was relevant to the user, there is no relevant area around the star to show that. This is a false negative, as we say. So in this case, what we do is that we sample around this false negative, retrieve more samples from the database, and if the user labels them, we can get more relevant samples as well as some irrelevant, and we can show in the next iteration that there is some prediction. So in this case, we see that the system has come up with a prediction. Here, this is the green area that we predicted. And this area doesn't exactly right now match the area we're looking for. So in this case, we sample around the boundaries of this area in order to improve our prediction. So if I label this, we can see that in this iteration, we have come up actually very close to the area the user is looking for. And we have an accuracy with only 61 samples of 93%, which is very good. So one common question here is that what types of queries can we predict? So obviously this is a range query. It's a disjunctive range query. So with our tool, we do not only predict range queries, conjunctive or disjunctive. We can also predict nonlinear queries, and I will show you right now. So if I use the same database, we have also a predefined query on these the same two attributes, row C and column C. If I select them, I'm at the same exploration page, and if I click start, we can see I will try to predict the circle query. So the only thing that the system actually needs to work is only one positive and one negative sample. So let's say here, I like this sample, this falls inside my circle that I will try to predict, and I don't like the sample. So if I click next iteration, we can see that the system has come up with a model as well as a new sample for the user to predict. The system at each iteration, it selects the best sample that will lead to a higher accuracy at the next iteration. So if I click next iteration, we can see that our model is not currently very close to the actual boundaries. If I click next iteration, you can see that we have actually we are actually much closer to the actual target area that we're looking to find. So the system at each iteration comes up with the best sample, and if we keep labeling the samples the system comes up with, we will end up with a better prediction. Sorry for labeling samples. Let's keep positive. Next iteration, positive. You can see that we come very close to the actual area with only 11 samples here. So we are already very close, and we have 12 samples. So this is our system. Hope you found it interesting. And let me know if you have any questions. You can use my email, kiki@cs.brandeis.edu. Or you can also, if you are interested in the system, you can also read our 2014 paper in SIGMOD which is Explore by Example, an automatic query steering framework for interactive data exploration. Or you can also read our paper in VLDB 2015, which is AIDE, an automatic user navigation system for interactive data exploration. Thank you for watching, and let me know if you have any questions. Thanks.